Solving equations containing radicals. The squaring property of equality states that if a equals to b, then a squared is equal to b squared. And we're going to use this property. Basically, it's saying if you square one side of the equation, you got to square the other side. And that goes hand in hand with solving equations. You know that if anything you do to one side, you've got to do to the other side of the equal sign. So, in order to solve an equation that has a square root in it, then you've got to do the opposite of a square root, which would be to square both sides. So, for example, my index for this particular problem is 2. And so what I need to do is I need to take care of that index by doing the opposite of the second root, which is actually squaring both sides. So I would square both sides of this equation. And what I'm going to have is x plus 1, because this square cancels out this index of 2, is equal to 5 squared, which is going to be 25. And so now to continue to solve, I'm going to minus 1 from both sides, and I'm going to get x is equal to 24. Now, make sure you check your solutions to make sure that they are actually solutions. So if I plug 24 back in here for x, I'm going to have the square root of 24 plus 1, and we want to know, does that equal 5? So that's a big question mark. 24 plus 1 is going to be 25, so you have the square root of 25, and that checks out. So 5 is equal to 5. So again, you don't have to do that physically, but make sure mentally you go back and check your solution, because it could be no solution. Okay, so let's try this one. Solve the following radical equation. We're going to square both sides. And so we're going to have the square is going to cancel out the radical, the square root. So you have 5x is equal to negative 5 times negative 5 is going to be 25. Divide both sides by 5, and we're going to get x is equal to 5. And again, when we plug that back in here, 5 times 5 is 25, and the square root of 25 is 5. But we have to talk about different types of when you take the square root of a number. So again, here, if I plug 5 in here, 5 times 5 is going to be 25, and the square root of 25 is 5. But technically, the square root of 25 is positive 5 and negative 5. And the reason being, because remember the opposite of a square, when I do negative 5 squared, I'm going to get 25. And then when I get 5 squared, I also get 25. But the problem with this is if this particular question is asking you the square root of 5x. It's not asking you what if you take the square root. In other words, if you initiate a square root, the square root's already in the problem. So this has to be equal to a positive number. And so since x is equal to 5, if I go in here and I do 5 times 5 and I get 25, and the square root of 25 is 5, not negative 5. So this is no solution. This case would be only if you have to initiate the square root. Here, the square root was already in the problem. And since the square root symbol was already in the problem, you're not going to do plus or minus. That's only if you have to put in the square root symbol in order to solve. Alright, so here are the steps. I've showed you the gist of it, but here are the steps to actually solving an equation that contains radicals. Number 1, arrange terms so that one radical is by itself on one side of the equation. That is, isolate the radical. This is important. That's going to be, if it's not already done for you, you've got to do that. Then you're going to square both sides of the equation to get rid of the radical. Simplify both sides of the equation if needed. And then if the equation still contains a radical, you're going to repeat steps 1 through 3. And then you would solve the equation and check your solution. Alright, so here, look, the radical is on the same side as this negative 1, and I need this to be by itself. So I need to get rid of this minus 1. So what I'm going to do is I'm going to add 1 to both sides. And so I have the square root of x minus 1 is equal to 1. And now I'm going to square both sides, and I'm going to have x minus 1 is equal to 1, and then if I add 1 to both sides, I get x is equal to 2. And if I plug 2 back into here to check the solution, I'm going to have 2 minus 1, which is going to be 1. Square root of 1 is 1, and then 1 minus 1 is giving you 0, so x equals 2. On this one, I have a 2x over here with this square root, so I need to get rid of that. So I'm going to minus 2x from both sides. So I'm going to have the square root of x minus 1 is equal to negative 2x plus 8. And then what I need to do is I need to square both sides. And so I'm going to have x minus 1 is equal to, now remember this is square double square. You got to write it twice. And then full it out, and when you full it out, you're going to get 4x squared minus 32x plus 64. Now, since I have a quadratic, we learned this in the previous chapter, since I have a quadratic, I've got to get it set equal to 0. So I'm going to minus x and add 1 to its like terms over here, minus x plus 1. And so what I'm going to have is 0 is equal to 4x squared minus 33x. Oh, I missed a sign here, sorry. I knew that wasn't right, so we're going to add, and then this will be minus 1 and minus. Sorry about that. Let's go back here. Alright, so we're going to have x plus 1 is equal to negative 2x plus 8 quantity squared. But what I'm going to have to do is full this out, and so when I do that, I'm going to have x plus 1 is equal to 4x squared minus 32x plus 64, and now I'm going to minus x minus 1. There we go, that's better. And do that to the like terms over here, so minus x minus 1. And so we have 0 is equal to 4x squared minus 33x plus 63. Now, to solve this, you know you got a factor, and that would be bottoms up or whatever it is that you do. And so we're going to have 4x, signs are going to be the same, and then 21 and 3. So again, do the bottoms up there. I'm not going to take the time to do it because I've already learned that. And then we're going to take each one of these and set them equal to 0. And so we have x is equal to 21 over 4, and we get x is equal to 3. And again, check your solution. So if I plug 21 over 4 in, watch what happens. I'm going to have 2 times 21 over 4 plus the square root of 21 over 4 plus 1. And we want to know, does that equal to 8? Well, so I'm going to have 21 over 2 plus square root of 25 over 4, and we want to know, does that equal to 8? So 21 over 2 plus 5 over 4, does that equal to 8? So here I need a 42 over 4 plus 5 over 4. Does that equal to 8? So we're going to have 47 over 4, and that does not equal 8. So this is not a solution. Again, check that. But if I go back and I plug 3 in, and I can do that one without writing that out. So 2 times 3 is going to be 6 plus 3 plus 1 is going to be the square root of 4, which is going to be 2, and 6 plus 2 is going to give me 8. So that one does check out. So again, make sure you check your answers. Alright, merging exponents and roots. So when you're talking about a square root, cube root, whatever, you're talking about fractional exponents, and we haven't really talked about that just yet. But I do want you to know that just because we're talking about exponents that are fractions, the rules that you've already learned do apply here. Okay, so don't worry about learning new rules. Now, here is your definition. If you have a base raised to a fraction, and I really want you to know this one because that encompasses this. So if you have a base raised to a fraction, what's going to happen is you can change that. These are interchangeable. You can change that to a radical, and it's always going to be power over index. So you have power over index. Okay, so notice your m is your power of your base, and your n is your index of your radical. So don't forget that. And again, you can go back and forth. So here, if I wanted to know what 25 to the 1/2 power is, well, 25 is my radicand, my base is my index, and my exponent is my power. So basically 25 to the 1/2 is asking you the square root of 25, which we know is 5. What about 8 to the 1/3? Well, that's asking the cube root of 8 to the first power. The cube root of 8 is going to be 2, and then of course 2 to the first power is 2. But what about down here? What if we have 8 to the 2/3 power? Again, we're going to have the cube root of 8 squared. And it doesn't matter which order you do this. You can square the 8 and then take the cube, or you can take the cube and then square it. And I personally think that's easiest because the cube root of 8 is 2, and 2 squared is going to be 4. Alright, so use radical notation to write the following and then simplify if possible. So, what if we had 81 to the 1/4? What would you put? Remember, 81 is your radicand, 4 is your index, and then of course 1 is the power. So basically it's asking you what is the 4th root of 81, and I showed you guys how to do that in your calculator, and so you should come up with 3. Try this one. Again, remember your rules do apply here. So basically what you have is 32 to the 1/5 power times x to the 10th to the 1/5 power. So we have power to a power. So now basically that's asking you what is the 5th root of 32 times x, power to a power, you multiply. So 10 times 1/5 is just going to be 2. So the 5th root of 32 is 2x squared. 2 times x squared is going to give you the x squared. What about this one? Basically this is asking you to take the cube root of both factors on the inside of the parentheses. So you have 16 to the 1/3 times x to the 7th raised to the 1/3. Alright, so 16 to the 1/3 is basically the cube root of 16. And then x to the 7th to the 1/3, basically that's saying times the cube root, and you can do 7/3 if you want to, the cube root of x to the 7th. So if you go ahead and multiply this out, you're going to have 7/3. It's still going to be power over index though. Okay, so 16, you can't take the cube root of 16, but it has a perfect cube factor in it. And so that's going to be 2 cube roots of 2. And then for your variables, remember we do 3 will go into 7 2 times with 1 left over. So that's going to be times, and we're going to bring an x squared out with 1 left over. So if we put all this together, we're going to have 2x squared on the outside times 2x on the inside. Alright, use radical notation to write the following and simplify if possible. So, what if we have negative 8 to the 4/3? So, that negative sign has nothing to do with that 4/3. So basically what we're doing is we're taking the opposite of the cube root of 8 raised to the 4th power. So the opposite of the cube root of 8 is 2 to the 4th power. And so 2 to the 4th power is 16, and the opposite of that is negative 16. So be careful where the negative sign is. And then for letter B, our base is a binomial. So you have to be able to look at it that way. Our base is a binomial. So our radicand is going to be this binomial. Our index is 3, so we're cubing it. and it's raised to the 7th power. So what you're going to do here is you can't pick these apart, so you're going to do 3 will go into 7. You're going to do your index into your power. So 3 will go into 7 2 times with 1 left over, which means we're going to bring 2 of those binomials out, and we're going to leave 1 underneath. So basically you're just using that exact same rule that we used, let's see, here. Alright, so here's another definition, and we have talked about this one as well. What if you have a to the negative exponent? Remember, anytime you have a negative exponent, you're going to flip it and change it to a positive, so don't forget that. So use radical notation to write the following. Simplify if possible. So in other words, sometimes you'll be able to simplify and sometimes you won't. But use radical notation to write the following. So this is exponential notation, and we need a radical. So what we're going to do is we're going to take care of this negative first. So we're going to do 1 over 64 to the positive 2/3. Then we're going to change it to radical notation. So we're going to have 1 over the cube root of 64 squared. And then we're going to have 1 over the cube root of 64 is going to be 4 squared, and then we're going to have 1 over 16. So with this one, be careful with your negatives. Be very careful with your negatives. That says to take the opposite of 1 over 16 to the positive 5/4. So we're going to have the opposite of 1 over the 4th root of 16 raised to the 5th power, power over index. And so we're going to have the opposite of 1 over the 4th root of 16 is going to be 2 to the 5th power. So we're going to have the opposite, or negative 1 over 32. So a couple more things that we need to talk about. So to write a radical expression using positive rational exponents, what you're going to do, remember the index is the denominator, the exponent is the numerator. So basically we're going to go opposite of what we've been doing. And then the radicand is the whole number. So this xy is your radicand. That's going to be your base. And then your index is 2, your power is 1. Remember, if you don't see an index, it's understood to be 2. If you don't see a power, it's understood to be 1. So we have x times y raised to the 1/2 power. And then we can separate that, x to the 1/2 times y to the 1/2. Let's try the one on the right. So again, we have a to the 3rd b as my base. And then I have a power, the power of this whole entire thing is 1 raised to, and then your index is going to be 4, so 1/4. So what we have here is a cubed raised to the 1/4 times b to the 1st, of course, raised to the 1/4. So what we're going to have is a to the 3/4 times b to the 1/4. So the next one, bottom left, the 4 is a coefficient. We're going to leave it out. So we're going to have 4 times x to the 2/3 power, which basically is 4x to the 2/3. So that square root has nothing to do with that 4, or the cube root rather. Alright, so for the last one, our base is a group, and then we're going to do power over index, and that's all you've got to do. Okay, use properties of exponents to simplify the following. Write results with only positive exponents. So let's look at this one. Remember, your exponent rules apply here. So what I have is I have power to a power, which means we multiply. These do not have like bases, so we cannot combine those. So instead, we're going to take each factor on the inside, 32 to the 1/5, and we're going to cube that, times x to the 2/3, and we're going to cube that. So this external exponent goes to every factor on the inside. Now, We have a power to a power, so we multiply. So we're going to have 32 to the 3/5 times x to the 6/3, and if you want to go ahead and reduce that, you can. And so now we're going to have the 5th root of 32 cubed times x squared. So now we're going to have the 5th root of 32 is 2 cubed times x squared, not cubed, x squared. And then we're going to have 8x squared. Okay, so let's try this one. So this one I have multiplication and division. I'm going to do the top first. I'm going to do the multiplication first. So now we have like bases. And so when we have like bases, we're going to add those exponents. When you multiply powers with like bases, you add those exponents. So we're going to have a to the, and you can put this in your calculator, 1/4 plus -1/2 is going to be -1/4 over a to the 2/3. Now, when you divide powers with like bases, you subtract the exponents. So what we're going to have is a to the -1/4 divided by a to the 2/3 basically is a to the, and you can put this in your calculator, -1/4 minus 2/3. -1/4 minus 2/3. And that's going to give us a to the -11/12. Again, put that in your calculator. Now, notice the directions say positive exponents only. So we learned earlier that when you have a negative exponent, you're going to take the reciprocal. And so we have 1 over a to the 11/12. So let's try these. Same thing, you have your power rules that you need to use. So here, it says rules for multiplying and dividing exponents still apply with irrational exponents. So you're not learning any new rules, you're just doing math with the same math with fractions now. So we're going to do coefficient times coefficient. 3 times 4 is going to give us 12. And then x to the 1/2 times x to the 2/3. We are multiplying powers with like bases, which means we add those exponents, so you can put that in your calculator. 1/2 plus 2/3 is going to give you x to the 7/6. Okay, here we have products to a power, which means every factor on the inside gets squared. Every base on the inside gets squared. So 5 squared is going to be 25. A to the 1/3 squared is going to be a to the 2/3. Power to a power, you multiply those exponents. And then b to the 1/2 squared is just going to be 1, so I'm just going to leave that as b. So when you do division, Alright, so when you divide powers with like bases, you subtract, but we can do the 12 divided by 6 first, and so 12 divided by 6 is going to give us 2, and then y to the 1/3 divided by y to the 1/2, again you subtract, top minus bottom, so 1/3 minus 1/2, again you can put that in your calculator, but you're going to have y to the -1/6, not 16, -1/6. So remember, we can't have a negative power, but remember the power of 2 is 1, so it's going to stay on top. And then the y to the 1/6 is going to go on bottom. So the last one, everything on the inside gets raised to the 4th power. So we're going to have 3 to the 4th power, x to the 2 to the 2/5 to the 4th power, and then we're going to have 2 to the 4th power and y to the 2/3 to the 4th power. So 3 to the 4th power is going to give us 81. X to the 2/5 raised to the 4/5 is going to give us x to the 8/5. And then on the bottom, 2 to the 4th power is going to give us 16. And y to the 2/3 raised to the 4th is going to be y to the 8/3. And you can't do anything with that. So the last thing that we're going to talk about is how to multiply or divide radicals with different indices. So remember in the previous section, when you're multiplying and dividing radicals, you got to have the same index. But what happens if you don't have the same index? Well, hopefully you'll have the same base. So watch this. When you multiply or divide radicals with unlike indices, then you got to get your radicand or your bases to be the same. And you're going to do this, once you have your bases to be the same, you're going to change it to fractional exponents. So again, remember it's power over index. So you have 2 to the first power, and your index here is 2. So 2 to the first power over 2. So which is going to be 1/2, and then 2 to the first power, and then 3, so you're going to have 2 to the 1/3. Now, when you multiply powers with like bases, you add those exponents, so this is going to turn out to be 2 raised to the 5/6 power. Again, put that in your calculator. 1/2 plus 1/3 is going to be 5/6. Now, since you started with radicals, algebra etiquette tells us that we have to change it back to radical form. So this is going to be the 6th root of 2 raised to the 5th power, or you can do the 6th root of 32. Either way. So for the bottom one here, notice our bases are not the same. Our radicands are not the same. So we need to change those. But look, the square root of 4 is 2. And then here we have 2 to the 1/3. So that makes it a little easy because this is 2 to the first power. So what I can do is I can do 2 to the 3 over 3 over 2 to the 1/3. And when you divide powers with like bases, you subtract top minus bottom. So 3/3 minus 1/3 is going to be 2/3. So we have 2 to the 2/3. Then we have to change it back to radical form. So we're going to have the cube root of 2 squared, which is going to be the cube root of 4.